had a few questions as I was walking around stamping, so I want to make sure to address everyone's questions before we get into the practice quiz, and then most especially when we get into the quiz. So you might have questions now, some more questions might pop up after the practice quiz, and then in between today and Wednesday, I want you to try to get all your questions answered and make sure that you reach out to me if you're still confused. Now, first of all, the total resistance in a parallel circuit. And this is in your physics helper, so you can use this for your quiz. Sorry, this is a series circuit. The total resistance in a series circuit is just the sum of the resistors. It's 5 plus 10, which equals 15 ohms. Unit is important, so make sure you know what unit we use for resistance. Any questions on that? Now, it didn't ask you to do this, but just in case I had a parallel circuit, like D, if I wanted to calculate the total resistance, does anyone remember what the formula is for the total resistance of a parallel circuit? Let me have Alex. You need to take the inverse of each resistor and add them together, and then take the inverse of that answer, right? So let's try it. For this one, I had 5 and 10. So I have 1 over 5 plus 1 over 10. If I do common denominators, I get 2 over 10 plus 1 over 10. Add those together, and I get an answer of 3 over 10. Is that my final answer? What is my last step? To find the total resistance, which is in the denominator. If I wanted my total resistance exactly, what do I have to do to my final answer? Let's start out like this. Let's say I had 1 over 3/10. What do I have to do? Nobody knows? Thomas. For all you have to do for this one, we're not going to do the calculation, but it's just a simplification of fractions. So if it's easier to just think about 3/10 as your answer, 3/10 when you do this calculation, you want to make sure to flip your answer, which is the same as what Vincent said. Multiply by the reciprocal. So when I add up the inverse of my resistors, my answer is not that total, but it is the reciprocal of that total. So it's not 3/10, it's 10/3 of an ohm. Or if you wanted to simplify it out, it would be 3 1/3 or 3.3 ohms. If you want decimals, that's fine. If you want fractions, that's fine with me as well. So 3 1/3, I want you to compare and contrast. In parallel, my total resistance is 15. In series, it's 3.3. That's less than each of these resistors by itself. So by lining up your resistors in parallel, you actually decrease the resistance significantly because it's like having multiple toll booths in a row. You have many options in which your current can pass. So it reduces the resistance. Any questions on resistance? Series is pretty easy. Parallel a little harder. The next one is on solving for current. If you're solving for the total current, you need the total voltage and the total resistance, which we got from here, and the total voltage, which this is the symbol for your battery. Make sure you memorize these symbols. Symbol for your battery is the positive, which is the long line, and the negative, which is the short line. And then your resistors are all little zigzags. If I divide my 30 by my 15, I get 2 amps, and that 2 amps is the same current that travels throughout my entire circuit, because there's no other place for my current to pass. It has one wire, and so it stays the same. It doesn't have any separate wires that I can separate through. This is what helps us answer our final problem. So, I want to look at this carefully. This group did the voltage drop. Did you guys go out this direction? So this is the 5 ohm resistor. And then this one is 10 ohm. Is that what you guys did in the back? Other way? Oh, okay. So 10 ohm. Okay. So we start off with 30. If we have a 10 ohm resistor, then what this group did was they got the voltage, but where did the 10 come from? Was that from 10 ohms? So we can't subtract total voltage, we can't subtract voltage from resistance. So we need to go back to our VIR triangle. If we're solving for the voltage, it's current times resistance. We already established that the current is 2 amps all the way across. So it's 2 amps through here, it's 2 amps through here, and all I have to do is multiply these two together to get the voltage drop through each resistor. In your concept builder, it was a little bit different because they asked you to find the voltage through this point, let's say, in between. But this one's asking you for something different. It's just asking you for how much voltage each resistor is going to absorb, and it's just current times resistance. So this one, for resistor 1, is going to be 20. So that's correct, but the work should be 2 amps times 10 ohms. So current times voltage current times resistance equals voltage. And then this next one is going to be 5 times 2. So we're multiplying 2 amps times 5 volts. And then this one gives us 10. If you add these two together, it should make up the total voltage that you started with, which is 30. But you want to make sure to understand the fact that current stays the same throughout the series circuit in order to do this problem. D is to draw a parallel circuit. With a parallel circuit, you want to make sure that your resistor is directly connected to the battery for both sides. So this one is connected to the battery, this one is also connected to the battery in its own individual loop. That's what makes it parallel. The resistance here is 5 and 10, which means that the total current that travels through is going to split up into individual branches. And the amount of current is dependent upon the amount of resistance. If the current is small, then the resistance is high. If the resistance is small, the current is high. So big current, little current, because it has high resistance and low resistance. So they're inversely proportional. The other thing I want to point out is the voltage drop. In a parallel circuit, the voltage drop, if it started off as 30 volts, it's going to be the same voltage drop through each resistor because they're both directly connected to the battery. And if we wanted to calculate this current, I use the cover-up method. 30 volts divided by 5 ohms, or 30 volts divided by 10 ohms, and calculate that for current. So let's see what we get by doing this division. 30 divided by 5 gives me 6 amps through here. 30 divided by 10 gives me 3 amps. And it matches what we thought would happen. We've got a high resistance, low current, and a low resistance, higher current. And since 6 amps is going through this resistor and 3 amps is going through that resistor, we know that the total current that came out of this battery is 6 plus 3, which is equal to 9 amps. You just add the current from the 2 branches together, and it splits out. And then when it comes back together down in this wire, if the current comes back down in this wire, then they're going to come back together and then again be a total of 9. It's like 2 pipes spreading out and then coming back as one. Any questions?
Where did you get the 9 from?
So it didn't ask for this, but basically I calculated the current from each one. And because I know this is 6 and this is 3, they came from the total current coming out of the battery. So basically if I added them together, I know what the total current is. It's 9. And then when they come back together in the end, they come back together as 9.